My name is Michael, and I was a web developer for a long time, for maybe 10 years or more. And I developed a testing framework, Codeception, and his JavaScript version, Codeception, to improve testing experience for developers. And I want to share this experience to everyone and make people use these great products. So I will be telling about this Codeception framework I developed and how its approaches improve the testing experience for everyone, a special web testing experience.
Okay, hello again, this is a smaller me, and it's cool that we here in cinema, so watch me like a 3D movie, and I think 3D should be real like that, like mixing theater and movies, and I'm the only actor on the stage. And I'll try not to be very boring, but probably I'll talk about stuff that may sound boring to some of you, but most of people who found out my keywords boring are in other halls. So everyone who wants to know more about PHP, Selenium, and how to do testing effectively, they're here. So let's start. Who am I? I was telling about myself a few words. So I'm working as a consultant and trainer at SDC Labs. But actually my journey started from the open source. I was a developer who wanted to improve the quality of his applications. I didn't find a proper approach to make it work with the set of tools I had, so I implemented my own testing framework, and years by years I improved it, so more people could use it and make more quality applications. So my motto here is like, make testing fun. So everyone should have opportunity to write tests. Tests should be simple to write, execute, and read. Yeah. So I started my career as PHP. PHP is a pretty common language, but it doesn't fit for everything. So it was around like 20 years. 20 years ago, it was hype. Yeah, 20 years ago, there was no hype, but PHP was really popular by the days. And I need to say, PHP is still pretty cool stuff, yeah. And it's not that bad. It's really good evolving. It's making better and better, and yeah, nowadays it can be used for automated testing as well. So when I'll be talking about PHP, let's think of modern PHP, not that old one PHP we had before. So PHP is still used on most of the websites, so you just think about that number. 81% of website of the internet we know is still PHP. So PHP is considered to be a simple language for everyone to start web development. So such things like e-commerce, they are mostly built with PHP. And PHP developers, they are pretty much of them, they're pretty cheap, they don't need to understand the deepest of details of implementation. They just build their tools, and they do it pretty great with tools like WordPress, Drupal, Magento as well, and Facebook and Wikipedia. They use PHP as well. What you need to know about PHP at first. So PHP is object-oriented language, and it, unlike other languages, it can be used for server-side web development. You can do more with it, but better not. And it has really strange architectural concept. Unlike all other languages, it just handles your request, processes it, and the process dies. So it restarts for every request you handle. There is no living server constantly. It just starts and dies. There are even command in PHP called die. It's really strange, but it works, and it solves lots of issues like memory overflow and so on and so on. It's really still working concept with its implementations. We had PHP to look like this. It was really hard to read, understand, and yeah, it was terrible, terrible, absolutely. So looking nowadays into this code, it makes you look like this. Probably the old PHP developers still look like this when they work. Don't touch my code. It works. It was perfect when I wrote it 10 years ago, and don't do anything with it. But today we have something new and modern ways to do stuff. So we are not mixing presentation and logic together. We are following MVC patterns. We have template engines. We have DDD, OOP. We can do even CQRS practice. So forget about this PHP. You won't see it anymore, I hope. So the strange things you need to understand when you get into PHP, and probably you will do it one day. So first is this, that all variables are prefixed with $signs. So, you know, there was a guy who was called Mark Zuckerberg. He wrote an application which made he a millionaire. He built this application by writing these $signs in PHP. I think it's not a coincidence. There's something more about it. So write more $signs and you'll be successful. Also, PHP has some really strange API because it uses C methods and strings. It's really hard to remember. There is no logic in them. So when you need to some array or string operations, you will always need to look into the manual. So it's okay, you need to deal with it. And some other stuff is inherited from this old PHP days because PHP never broke compatibility in a hard way. So it's still compatible with the very old edition. It still supports procedural programming, HTML and PHP, but we are not writing the code like this nowadays. So yeah, if you still, this is how you can be hired to work on PHP. Because no one wants to work in PHP. But still, it's a really good language. It's not hype anymore. Modern PHP looks much better. So if you're familiar with Java, you can actually read this code because OOP, the style is inherited from Java. So PHP just took this object-oriented model, even added annotations, and then the code became pretty modern and pretty readable and nice. And PHP developers look much nicer today. So as I said, we have Java style OP, namespaces, annotation, autoloading, coding standard, which is really impressive. I think in JavaScript there is still no coding standards. We have single key package manager. So if you ever tried PHP like 5 years ago or more, it's absolutely new stuff here, and you need to reload all your knowledge about PHP today. And so how do we deal with Selenium WebDrivers? How do we write automated tests in PHP, and how we want to automate browsers? Sure, we won't do it without Selenium. Unfortunately, we don't have any library which implements the WebDriver protocol officially, so there is no official Selenium bindings for PHP. But still, you remember that guy, Mark Zuckerberg, he was called. He established a company, and this company created bindings for PHP WebDriver. Yeah, and I think we can trust that company. We trust them too much personal information, so we can trust them in our jobs as well. We will use the PHP WebDriver implementation, which looks really nice. It's have nice license. Its API is really consistent with Java bindings, and you can read it from this slide. So if you're familiar with Java, just you remember the $signs, yeah? Just skip them, and everything else is pretty readable. So if you don't know how to do some stuff in PHP, you just can Google the Java solution, copy and paste it into PHP code, add $signs, and it will work. So API is absolutely consistent, yeah. And you can work with it, you can really understand it well if you know the original Java API. And in PHP world, we have 3 major testing frameworks. As a developer of last one, I will concentrate on it, because actually it has the best support of Selenium WebDriver, and it's the best suitable for non-PHP developers to come in. So you can start writing tests with all those basic about PHP I told you, and you can easily start using it. So I name Codeception as BDD style testing framework. So you can do BDD in Cucumber Durkin, but it's not the only purpose and not the only case. So we take from BDD the readability, the maintainability. So tests are clean. We concentrate on the testing requirements, on the scenarios, and not on coding, not on implementation. So this separation of presentation and implementation is the key feature of Codeception. So we use high-level API. We have everything needed for test automation, and on the end we have really readable tests. So here is how Codeception can be installed. So we need to receive this GIF from the beginning. So actually it's just like executing one command. So in it, answering a few questions in Wizard, starting a Selenium server. I hope you already have it started. And when you do it, you can just have a running test which opens a browser. Yeah. So the code inside Codeception will look like this. You see, it's absolutely readable. Yeah. You can easily follow what's happening. Unlike the WebDriver pure implementation, we skip this idea of web elements. So we write our code like scenario, what I'm going to do on the website and what I want to see. Yeah, the only assertion we had have C prefix. And if you will remove all the extra signs, this can be readable by non-technical persons like even HRs, like business analysts. So everyone can read those tests if you teach them to do it. Yeah, just remove special chars. Most of stuff is readable. And what you need to understand, what you saw, this I object which performs action. So the test is explained like I am opening a page, I am filling some forms, I am clicking buttons, and I want to see something on a page. And this means that all the tests are written from this user perspective. And as I said, we are focusing on this scenario itself without hooking up into implementation. For instance, we don't care which locator tab you provide. It can be CSS, XPath. If you are clicking button, probably you can provide its value like button text or link text. So whatever is easier to understand what you need to click. So you can use field labels to fill fields in. Yeah, so it's really flexible, and you need to specify which type of locator you need. It will guess by the locator type. And yeah, we have page objects. Page objects are like, I think maybe look like in Java, because they are just classes which you can define locators, methods, and you can inject those page objects in your tests to make them not just readable, but compact and reusable. So if you need to view a task, we probably need to create it first. And we can reuse this method from task page to have it. So, and you see we are using the dependency injection here to get it. We just specify the class name we need to use. It's injected in method, and we can use methods. By the way, PHP is have all the features of statically typed language, so you will have auto-completion from your IDE, and it's so writing tests from it, you're like choosing I select method, click I select method from a list, C. So it's just choosing the right method and putting the right params, no more, nothing more. And when we execute this test on this previous slide, we will see this report in console output. So it's what you see by default, actually. So when we inject, we can see all the steps are written in human readable manner. And when we injected page object, we have it expanded. Yeah, so we had we know that we are creating tasks, and we are step by step seeing how it was created. So it's easy for debugging, easy to following what's happening when, in a test. So you won't see a 3 minutes of blank screen when you are executing a test. You will see its execution, how it goes step by step. And when we create more and more complicated scenarios, we will come to this the tests which may look like this. It's far more complicated, but it's still compact and it's still readable. So we are using page objects to create data. We are using other page objects to interact with other kind of data, and so on and so on. And still, the code is absolutely perfectly readable. You can focus on what is happening. It's really easy to refactor because it was shown on the slide of the page object. It's just the same API. You just copy out from the test the code you are repeating, create a method, and you call it here. Yeah. And we use annotation to delete the website after the test when the test finishes. So this annotation also helps us to move out all the stuff that doesn't belong to test. If we are only editing the website, we need to focus on this precise scenario. And when we execute it, we still see all the fields, how they're filled, how the operation came, and yeah, it's really easy to follow. When we are talking about reports, so console report is probably the most helpful one, but we have XML reports for Jenkins CI, we have HTML reports in BDD style, and code coverage reports, so you can even collect code coverage with it. HTML reports look like this, so you can see step-by-step output for each test, and when test failed, you even see screenshot of the last failure. So it's really helpful on CI systems when you don't have a browser window to watch the test execution, but you at least have some clues in the end, how did it pass and why did it fail. And Codeception was started as a BDD-style testing framework. As you see, it's not about BDD how we understand it today. So we don't talk about the business requirements here. We just talk about the business scenarios, how we do stuff, how we follow the scenario. But what if we need to have a real BDD, like the Cucumber does? What if we need to concentrate on business language? In this case, we are having like the even higher API written in Gherkin. So you are familiar with this syntax, given when then and scenario background feature. So some features can be described in this way and also executed as a test. So each step we were writing in BDD, then we will have these steps implemented in Codeception in the same API we had. We mark it with annotations that this is this step. I create new. Oh, yeah, I create new content, and yeah, we have it here. So this step will be executed. That means that we still have the meta step, like create new content, which we can use everywhere, and especially in these Gherkin scenarios. What I really like about this BDD implementation is that it solves some problem people don't usually think about. So when they start introducing BDD tools like Cucumber in their projects, they start describing features as they go. But then they're transforming these features to tests, and then they add regression tests to the suite. And when they add regression tests, they're describing this regression test scenario. And all the scenarios start with a feature. But no, we are not adding a feature new here. We're just adding, reproducing a bug, and we are assuring that it's not fixed. So in BDD, we always mix the business valued stuff with tests. In Codeception, you can separate them. So in Codeception, you can implement one business value test, which will be read by business analysts, by management team, which actually represents the state of the system from a business way, while writing more and more test automation, and without pushing this trash into the business domain. So they don't want to, they actually, most cases, business owners don't care what the error message will be on website. They just want to, there will be error message and you as engineer need to provide it. It's not a part of my business how it will be. And in this case, you can separate, so have one feature description which will have a happy path test for a feature and have more and more unhappy paths, negative scenarios which will be tested in similar manner. But as a test, they will be absolutely the same. So they will be executed in one stack, and you can reuse steps from those things. So Codeception can handle both cases. Yeah, and some pretty common stuff for test automation, especially with browser. How do we handle asynchronity? It's usually we put lots of these commands like wait for element in our tests. Yeah, Codeception has them, and they are pretty flexible as well. They are nice API. And in recent versions, we even added some cool APIs like called smart waits. If you ever used Selenium implicit waits, who heard of Selenium implicit waits? Have you used it? So they're really tricky because they check for the presence of element. And if you add them for all the tests, you will have them stuck on the situations where element is not on page. You are checking that element is not on page, but it will wait for this element to appear. So if you use them unwisely, you will end up with long run tests. So what we do here, we just turn out this implicit waits for the situation. We check for element to be on page. Like before clicking element, we can wait for 5 seconds, maybe it will appear. And then we turn it off. So mostly this is like implicit waits turned off. So they have their own benefits, and it's really improves the test readability and test execution, this smart wait feature. And some more stuff we have. So interactive console, you can pick up all those commands like click them on a page, try them in the console and see how it executes in your browser. And there are session snapshots. For instance, you can log in once in a test and then reuse the same login session for all other tests. So you won't need to log out and log in and spend time on this. And we even have multi-session testing if you need to open 2 browsers for 2 concurrent users and have them sending message to each other. We handle this too. So probably we have everything needs for web automation and even more. People don't even talk about how we manage data in tests, especially in such complex tests like for acceptance tests. But Codeception is like full stack framework. We have lots of different options to handle, and the test data management we have too. So there are modules that allow you to connect to database, insert or delete records you need for this precise test, and reuse it in your test and then clean it up. Maybe it's not really clean approach to go to database directly. If so, you can use the REST API to do the same stuff, but with a public API, which is considered stable. And it's really smart and good approach to not create all the items you need from the web interface, but use it like REST API. So instead of clicking 5 fields and using 3 pages, you can send 1 post request and use its data in your tests. And another option is accessing PHP directly. If you have a good API of PHP and the PHP developers provide you with this API, you can mix logic, use some domain-specific things from PHP, create data, clean up it afterwards, and so on. So there are different options you can use, and which better suits for you, it depends on your project. About architecture. When we call this iClick, this iObject is an abstraction over the different modules. And the idea here is that you can switch modules and the implementation. So when we execute iClick, you don't know who will handle this. So in this, on this presentation, I was showing how WebDriver module handles iClick. it will open browser and perform real clicks there. But you can emulate browser with the frameworks. You can emulate browser with curl. So there are different options of emulation. So, and the API is still the same. And the iObject proxifies this call to modules. You can add more modules, use different modules for database access, for instance, for Redis, and so on, and create your custom modules. So if you need to create some stuff with Selenium code and some really complex action, you can create your own helper and create the method for it. So you won't ever use raw Selenium API in your test, because you need in test you need to be focused on a test scenario. If you need some raw low-level stuff, you implement it as a helper and reuse it via this iObject. So all the tests should be like I with usage of PageObjects and so on, but no direct calls to any services. This all should be hidden in helpers. And yeah, I'm mostly finished. So Codeception is a full-stack testing framework. I was talking about acceptance testing, browser test automation mostly. But we also handle unit, functional integration, and so on. And that can be problem for newcomers, because they just install this big tool and they don't know what to do with it. Right now we are focusing to make it more usable for junior testers, for people non-common with PHP background. For instance, we have this init acceptance command I showed you in a GIF, which prepares you setup for the browser testing. Yeah. So Codeception has really good integration with WebDriver, and you can use it for probably all the complex scenarios. Codeception is used for big companies, so I won't call commercial companies, but I'm sure some names like Joomla or Magento is pretty means something PHP world, so it's already used by big open source projects. And what I need you to understand the most, it's the best practice. Separate test from implementation. Move this as a implementation logic out of your test. Whatever testing framework you will develop, you will still need to follow this paradigm, because tests should live with application. Tests should be easily to update, to delete when the requirement that doesn't fit in. And if your test will be just some code which is hard to follow, you will end up with just commenting it out, trying some things. But if you have it clean, small, and easy to follow, you will always have a successful test automation. Thank you.